In section 3.1, we start to use the significance level that we learned about in section 2.3 to make decisions about whether or not to reject the null hypothesis. So in exploration 3.1, I'm starting on page 2, so if you haven't already, you should pause the video, make sure you read through the opening of the exploration to understand the scenario and try answering the first 7 questions yourself. I just wanted to mention in number 7, when we're using the applet, I put on the left, in the column there on the left, what I entered into the applet. Make sure you selected proportion of heads instead of number of heads. And of course we use the count box to find our p-value, and we chose the greater than or equal to match the direction of the alternative hypothesis that couples tend to lean to the right when they kiss, so more than half of them will lean to the right when they kiss. And the p-value that I got from that was 0 out of 1,000, and you might not have gotten exactly that. Maybe you got 1 or 2 out of 1,000, but you should have a very small p-value, which gives very strong evidence against the null hypothesis. So we have very strong evidence that couples tend to lean to the right when they're kissing. So, as it says here, having that very strong evidence leads us to a follow-up question: how much more than half the time? So we have very strong evidence that the parameter value is greater than a half, but how much greater than a half is it? So in number 8, we're going to test whether the data provide evidence that the probability that a couple leans their heads to the right while kissing is different from 0.6. So note to self, first of all, I now have 2 different hypotheses. My null hypothesis is no longer that pi equals 0.5, it's now pi equal 0.6. So I'm going to start by assuming that 60% is correct in the truth for the whole population of the proportion of couples who lean to the right when they kiss. And my alternative is going to be that pi is not equal to or different from 0.6. Now in the applet, the only thing I had to change was in the top box. I had to change the proportion of successes to 0.6. And as soon as I clicked out of the box, it did change from saying proportion of heads to proportion of successes. And instead of saying number of tosses, in the second box it says sample size n, which is still 124, and we're still doing 1,000 repetitions. And the same number is going into the count box as before, because we still have the same p-hat value statistic from the sample. And when I did that, I got a p-value of 170 out of 1,000, or 0.170, which, if you look in your guidelines, is weak evidence against the null hypothesis, which means the null hypothesis is plausible, which means that it's plausible that the parameter value is 0.6 and that 60% of all couples lean to the right when they're kissing. All right, then we have this think about it that reminded us that if we hadn't remembered, and I purposely didn't remember for demonstration, we should have been doing a 2-sided test because of the not equal to symbol in the alternative hypothesis. So if you go back, if you hadn't already done this, and maybe you did, which is great, if you hadn't already done this, you can go back to the applet and check the 2-sided box. And when I did that, and remember, you're not necessarily getting the same p-value as me, and that's fine. In the right end of the graph, 170 dots were at or above 0.645, and then to make it 2-sided, in the left end of the graph, another 152 dots were counted, and that was a total of 322 out of 1,000, or 0.322. So note to self, that's still weak evidence against the null hypothesis. In fact, it's even weaker evidence than we had before. So it's still plausible that pi equals 0.6. Okay, so then we remember from section 2.3 this thing called a level of significance. Remember, the symbol for that is alpha, the Greek letter alpha. And so the key idea here, we will consider a value of the parameter to be plausible if the 2-sided p-value for testing that parameter value is larger than the level of significance. So they mentioned that 0.05 is kind of a common level of significance. So they ask in number 9, is the p-value less than 0.05? So the p-value is 0.322, and that in fact is greater than, that is greater than 0.05. That means we cannot reject, we fail to reject 0.6, which means if we're not rejecting it, 0.6 is a plausible value. So we come to the same conclusion that we did in the hypothesis test, that it's plausible that the parameter value is 0.6. So remember, at the beginning of this exploration, we started with the null hypothesis of pi equal 0.5, and we got a very small p-value, and we said, well, that's not plausible. What's plausible is that pi is bigger than 0.5, and now we've tested an actual value that is bigger than 0.5. We tested 0.6, and we found that 0.6 is a plausible value for pi, the probability of a couple, meaning the proportion of all couples that lean to the right while kissing.